On Mars, there is a silent graveyard. No headstones, no flowers, no visitors. Just the rusted silence of a planet that has been dead for billions of years. And somewhere on its surface, a machine, the size of a golf cart, lies buried to its axles in soil it never managed to escape. It has been there for over 15 years, and it will remain there for millions more. Yet, before it fell silent, this single robot changed everything we thought we knew about the red planet, rewriting the history of Mars itself. Today, we delve into the full story of the Spirit Rover, a machine launched on a 90-Sol mission that miraculously continued for over 2000, a robot that stumbled into groundbreaking discoveries by accident, that dragged a broken wheel across an alien world and still managed to rewrite the history of Mars. This is a tale of failure, resilience, and what happens when a robot simply refuses to give up. Let's begin at the very start. The year is January 2004. Spirit had just endured one of the most violent arrivals in the history of planetary exploration. After a 7-month cruise through interplanetary space, the spacecraft carrying Spirit slammed into Mars' atmosphere, traveling at over 19,500 kilometers per hour. It possessed no engines to slow its descent. Instead, it relied on a robust heat shield, a massive parachute, and an extraordinary system of airbags that inflated around the lander in the final seconds, transforming it into a bouncing, tumbling ball of foam and metal. Spirit hit the ground, bounced dozens of meters into the air, hit again and again, rolling nearly a kilometer before finally coming to rest inside Geological crater, a 166-kilometer wide basin that scientists believed might once have been filled with water. The mission had a singular, focused objective: to find geological evidence for the past presence of water on Mars. If water had existed there, Mars was not always the frozen desert it is today. And if it wasn't always a frozen desert, then at some point in its ancient past, it might have been capable of supporting life. No pressure, right? Spirit's scientific toolkit was purpose-built for this crucial investigation. The rock abrasion tool, or RAT, could grind away the outer surface of a rock, exposing fresh material untouched by the Martian atmosphere. The microscopic imager captured intricate close-up details of rock textures and grain structure. The alpha particle X-ray spectrometer measured the elemental composition of samples, while the Moosbauer spectrometer identified specific iron-bearing minerals. And of course, a comprehensive suite of cameras allowed Spirit to navigate, survey, and photograph its surroundings in stunning detail. It was an impressive payload, indeed. But within days of landing, this impressive payload almost became irrelevant. On Sol 18, Spirit went silent. This wasn't a temporary glitch, it was a complete communications failure. The rover stopped responding to commands, transmitting only fragmented, corrupted data. Back at the Jet Propulsion Laboratory in Pasadena, engineers worked tirelessly around the clock to diagnose the problem. What they discovered was alarming: Spirit's flash memory, the storage system that retains data even when the rover powers down, had become so overloaded with files that the system was trapped in a continuous reboot loop. Every time Spirit attempted to start up, it immediately crashed and restarted. The solution required sending a complex software patch across 142 million kilometers of space, essentially reformatting a critical piece of hardware on a robot they could not physically touch. It took 2 weeks, but it worked. Barely 6 weeks into its mission, Spirit had already demonstrated something profoundly important: it could be saved, and, more significantly, the dedicated people operating it were not going to give up easily. With communications finally restored, Spirit began its true work, and the red planet slowly began to reveal its secrets. The floor of Geological crater, it turned out, was largely covered in volcanic rock. While water may have once filled the basin, billions of years of geological activity had buried any sedimentary evidence beneath vast lava flows. It was frustrating. Spirit was sitting inside what scientists had hoped was a dried lakebed, but the surface told a different story. So, the team looked further. Roughly 3 kilometers to the east, a series of low hills rose above the crater floor, the Columbia Hills, named after the Space Shuttle Columbia and its crew, tragically lost the year before Spirit launched. These hills were never part of the original plan, they were considered too far, beyond what Spirit was realistically expected to reach. But with the rover performing beyond all expectations, NASA decided to try. What followed was an arduous 3-kilometer drive across terrain littered with rocks, dunes, and loose soil, a journey that took months and pushed both the rover and its operators to their absolute limits. Yet, when Spirit finally began climbing into the Columbia Hills on Sol 156, it discovered something entirely different from the volcanic plains below, rocks that showed clear signs of alteration by water. The hills told a story the crater floor had kept hidden, minerals that form only in the presence of liquid water, and textures consistent with prolonged exposure to aqueous environments. The mission's central objective, to find evidence of water, was already being met. And Spirit was only a fraction of the way through its life. Spirit spent the next several hundred sols meticulously exploring the Columbia Hills. Each stop yielded new data, and each rock analysis added another crucial piece to Mars' geological history. Among the finds were Wish Stone, a finely grained volcanic rock displaying signs of chemical weathering, and Watchtower, a layered outcrop packed with information about ancient volcanic and hydrothermal processes. But perhaps the most striking discovery of this period was Paso Robles. During a routine maneuver, Spirit's wheels accidentally churned up a patch of soil that turned out to contain extraordinarily high concentrations of salt and phosphorus. This discovery was entirely unplanned. Spirit had simply been driving, repositioning itself, and in doing so, exposed something that would have otherwise remained buried. The salt content alone was remarkable, with levels suggesting that large quantities of liquid water had once moved through that area, depositing minerals as it evaporated or froze. It was a profound reminder that some of the most important scientific discoveries are not found by looking in the right place, but by accidentally looking in the wrong one. Meanwhile, Spirit continued its ascent. Husband Hill, the tallest peak in the Columbia Hills, rising roughly 100 meters above the crater floor, had become its next major target. The climb was slow and energy-intensive. During this period, the Martian atmosphere was thickening with dust, significantly reducing the amount of sunlight reaching Spirit's solar panels and threatening to cut power levels below the minimum required for safe operations. Then, on Sol 421, something truly remarkable occurred. A Martian dust devil swept directly over the rover. These atmospheric vortices are common on Mars, towering columns of spinning air that can grow hundreds of meters tall and scour the surface clean as they pass. And that is precisely what this one did. In a matter of minutes, a year's worth of dust accumulation was lifted from Spirit's solar panels, and the rover's power generation jumped from roughly 60% of its original capacity back to over 90%. Nobody at JPL had scheduled that. It was the planet itself, in some small, serendipitous way, extending Spirit's life. On Sol 581, Spirit reached the summit of Husband Hill. It paused there, doing what any explorer would do after an exhausting climb. It looked around. The panoramic image Spirit captured from that summit remains one of the most striking photographs ever taken on another planet. Hundreds of frames were stitched together into a sweeping view that stretched to the Martian horizon in every direction: the Columbia Hills, the flat plains of Gusev Crater below, the distant ridgelines of McCool Hill and Ramon Hill catching the thin Martian light. And in the foreground, Spirit's own deck, clean and dustless, bore silent evidence of those life-saving dust devils. From the summit, Spirit also imaged both of Mars' moons, Phobos and Deimos, capturing them crossing the night sky in long photographic sequences designed to improve measurements of their orbital paths. Even at rest, the rover was relentlessly working. The descent from Husband Hill would prove equally productive. On Sol 690, Spirit's instruments analyzed a rock named Comanche and found something extraordinary. Roughly 1/4 of the rock was composed of magnesium iron carbonates, a concentration approximately 10 times higher than anything previously measured on Mars. Carbonates are minerals that form in the presence of liquid water, but they are destroyed by acidic conditions. Their presence in such high concentrations indicated that at some point in Mars' history, there existed bodies of water that were neutral or even mildly alkaline, conditions far more hospitable to microbial life than the acidic environment suggested by other Martian geological records. It was a significant recalibration of the picture scientists had been building. Mars had not always been hostile in the same way, it had been different kinds of hostile at different times, and in some of those times, something may indeed have had a chance. At the base of the Columbia Hills, Spirit arrived at one of the most geologically interesting features of its entire mission, home plate, a raised, roughly circular formation of layered and eroded rock approximately 90 meters across. The structure's origins were debated, but the layering patterns and rock chemistry pointed toward explosive volcanic activity, possibly an ancient eruption that sent superheated material blasting across a wet surface, baking mud and sediment into the layered formation Spirit could now examine up close. The edges of home plate displayed features difficult to explain without invoking flowing water or steam, carved surfaces, unusual mineral distributions, the kind of evidence that makes geologists reach for their notebooks. But March 2006 brought a development that would change everything. One of Spirit's 6 wheels seized entirely. The right front wheel had been showing signs of increasing friction for months, and now it stopped turning completely. Engineers at JPL ran exhaustive simulations on identical hardware back on Earth, trying everything imaginable to restore function. Nothing worked. Spirit would spend the rest of its operational life dragging that wheel behind it, a locked metal disc carving a continuous groove through the Martian soil. And that groove, unexpectedly, would change history. In March 2007, as Spirit was navigating around the western edge of home plate, the dragging wheel gouged through the rust-red surface layer and exposed something startlingly bright beneath, almost white and completely unlike the surrounding terrain. It was silica, nearly pure silica, concentrated at levels that matched only 2 known geological processes: hydrothermal hot springs, where water dissolves silica in one location and deposits it elsewhere as it cools, or fumaroles, where steam and volcanic gases blast through rock, stripping away other minerals and leaving silica behind. On Earth, both environments are places where life thrives. This discovery, made entirely because a wheel had failed, because the rover kept going anyway, and because the dragging mechanism happened to cut through exactly the right patch of ground, was described by scientists as the most significant find of Spirit's entire mission. Had Spirit been healthy, it would have driven straight over that patch without disturbing it. The broken wheel was not a limitation, it was, in fact, an instrument. The months that followed were quieter, yet not without purpose. Spirit continued to circle home plate, meticulously documenting its geology, capturing atmospheric data, and sending back images that would take scientists years to fully analyze. In June 2007, another fortuitous dust-cleaning event pushed power generation back above 600 watt-hours. The machine was still alive, but the Martian environment is patient in a way that machines are not. By 2009, 2 of Spirit's 6 wheels were no longer functioning. Dust storms had returned, coating the solar panels and severely cutting available energy. Memory anomalies were beginning to appear, clear signs of aging components under sustained stress. The rover's power generation was hovering dangerously close to the minimum required to keep its internal heaters running. Without that essential heat, the electronic components would inevitably fail. Then, on Sol 1892, Spirit drove into a patch of soil it could not escape. The location was aptly named Troy. Beneath the deceptive, rust-colored surface crust was a deep layer of extremely fine, loose material, jarosite, an iron sulfate mineral with almost no cohesion. Spirit's wheels spun without gaining traction, and every attempt to move dug the rover deeper. For months, engineers on Earth constructed a replica of the trap in a JPL testing facility, trying combination after combination of wheel movements, driving angles, and extrication sequences. None of them, however, managed to free Spirit. On Sol 2155, NASA formally reclassified Spirit as a stationary research platform. It was not an ending, not yet. From its fixed position at Troy, Spirit continued to study the Martian atmosphere, examine the soil beneath its belly, and build up the long-term meteorological record that only a stationary instrument can provide. Its robotic arms still functioned well, its cameras still worked. It was no longer going anywhere, but it had certainly not stopped doing science. The final winter came in the southern Martian autumn of 2010. Temperatures plummeted, and power generation steadily fell. On Sol 2196, Spirit's available energy dropped back to the critical threshold of 150 watt-hours, the absolute minimum required to maintain the heater systems that kept its electronics alive. Communication attempts became less frequent, as the rover needed every single watt it could collect just to survive the night. Sometime around Sol 2208, Spirit experienced a low-power fault. The last confirmed communication from Spirit was received on March 22, 2010. After that, only silence. Spirit traveled 73 kilometers across the surface of Mars. It operated for 2,088 Martian sols, more than 23 times its intended mission duration. It transmitted over 128,000 images. It found compelling evidence of ancient water, ancient volcanic activity, and ancient hydrothermal environments that, on Earth, would be called cradles of life. It achieved all of this because it kept going long after it was expected to stop, because the dedicated people running it refused to give up, and because a broken will unexpectedly turned out to be a gift. Today, the Perseverance rover, currently operating in Jezero crater, carries with it a small piece of tribute to the missions that came before, a family portrait of the Mars vehicles, with Spirit proudly among them. And somewhere on the slope just west of home plate, in the long Martian night, the rover that refused to quit is still out there, frozen, silent, exactly where it fell. Yet, the data it collected is still being studied. The maps it made are still being used. The questions it raised are still being answered. Some missions simply end. Others, however, become the very foundation for everything that comes next.